This would be a pretty good look at what we know the atom to be today. It actually has the nucleus in the center, and it has this kind of fuzz here is the electron cloud in general. I like this slide because at the bottom in italics it says if you were to have a balloon, a massive balloon that was 10 stories high, that's very high. So if each story is maybe 10 feet, so it's about 100 feet high. And then in the middle, about the 5th floor, you could have the nucleus. Okay, this is to scale. And to scale with that volume, the nucleus would be the size of a BB. Is that not cool or what? So that BB actually, surrounded by all of that empty space, actually atoms are mostly empty space. That is so cool. So when you see a drawing like this, it's not really drawn to scale. The nucleus is much smaller than that relative to kind of the space where the electrons are and what we call the electron cloud. But like this slide says, and when we'll note it here in a minute, in the nucleus, actually, that's where almost all of the mass is found in an atom. I just think atoms are so amazing. We're going to talk about 3 subatomic particles, and I like to tease it. If you are a physicist, actually you talk about how these major subatomic particles are further broken down into other smaller particles, but we're going to go with the protons and the neutrons and the electrons. I'll talk a little bit about both. We've been kind of saying a little bit. So this is showing you the nucleus in the center here, okay, and then kind of the electron cloud. It just happens that we have, 1, 2, 3 electrons out here, and the center, it, to me, looks like 3 protons and maybe 3 neutrons. They're showing the protons are red and the neutrons are blue. This actually, by the way, remember if you grab your periodic table, I said that that whole number there in the periodic table tells you, it's the atomic number, tells you the number of protons. This must be the element lithium. See how that works? Because it has 3 protons. Anyway, this is kind of generally what we have when we look at an atom. To try to tell you kind of how much empty space atoms are, or excuse me, to tell you how small atoms are. This says if every atom within a pebble, okay, was the size of a pebble itself, so scale up an atom within a pebble and make it the size of the pebble itself, then the pebble would actually volume-wise be larger than Mount Everest. Now I know not all pebbles are created equal, but just think of a pebble in a sand. All those atoms, scale them up to the size of the pebble, and that pebble now would be the size of the volume larger than Mount Everest. Is that not cool or what? Okay, so atoms are very small. Just ignore my dogs, they are just fine. Okay, so what do you need to know about these subatomic particles? Well, protons are positively charged. That's why I've been kind of doing this sort of thing for a proton. They're positively charged with what we call kind of one charge unit. Where are protons located? Well, they're located in the center of an atom in what we call the nucleus. We're going to see that neutrons are also in the nucleus. Protons actually help hold the electrons to the atom. So protons are positively charged. We're going to find out that electrons are, guess what, negatively charged, which you maybe already know. And there is an attraction of these to each other. So they're kind of held together by electrostatic forces. So protons are in the nucleus and neutrons are also in the nucleus. And we said in the nucleus, actually, in the center of the atom is where the mass is. So those 2 particles, protons and neutrons, actually give the mass to the atom, most of the mass. And we said that actually on a periodic table, the number of protons is always listed, and actually the number of protons in the nucleus of an atom says what element you have. So for instance, a little bit ago, we said that if the number of protons is equal to 3, okay, we said that means that must be a lithium atom. Okay, if the number of protons is equal to fill in the blank, you should be able to use a periodic table and see what element that atom is. Need to know about the neutrons. The neutrons are neutrally charged. So oftentimes we'll do N for standing for neutrons, and we'll do a superscript 0 for that's the charge of 0. They're neutrally charged. They're not attracted to the protons or the electrons nor themselves. The neutrons, as I said, are also found in the nucleus with the protons. The neutrons then help the protons to coexist. So we said that actually protons were attracted, protons and electrons are attracted to each other, okay? Unlike is drawn to unlike. Well, like repels like. So as I go ahead in the lithium atom, have these 3 protons, actually they are wanting to eject each other. So there actually is a repellent force. And it is the presence of the neutrons, I'll go ahead and put 3 neutrons in here, that kind of helps dilute that sort of pushing out that they want to do. So we say the neutrons help the protons coexist in the nucleus. This is kind of a, we already said as much, so in the nucleus we have protons and neutrons, and the protons, we're actually going to say they weigh 1 AMU, and also the protons also weigh 1 AMU. So we say that protons and the neutrons basically weigh the same as each other, and they're what gives mass to the atom. Electrons don't really weigh much at all. So electrons are negatively charged. So as you might imagine, the symbol for electrons is an E with a superscript negative. What else do we know about the electrons or need to know? Well, we saw that actually after Dalton, we saw that, well, actually Thomson was a plum pudding, but then beginning with Rutherford, we saw that electrons were outside the nucleus. The electrons actually give the atom volume. We're going to be talking how big is an atom, what's the volume of an atom, and we're going to see it's the electrons that basically kind of give you your 10-story building. Okay. Electrons, as it turns out, when atoms join together, I'll go ahead and make a water molecule up here. So H2O, we have an oxygen in the middle, and we have it bonded to 2 hydrogen atoms. And what we're gonna talk about this later, but it's about the electrons, okay, in all 3 of those atoms that kind of make these chemical bonds possible. So it's about the electrons that make chemical bonds. And then it's also about the electrons whenever we have, remember what chemical reactions are? New substances are formed. Chemical reactions occur as chemical bonds are broken and as chemical bonds are formed. And it's the electron there. So again, I don't have this to animate. One of these times I need to go back and try to make this animate. But if I were to be able to animate it, all it would show you, do you know what I'm going to say? Which of these 3 subatomic particles, the neutrons or protons in the nucleus or the electron cloud, has the most motion? It's the electrons in the electron cloud that has motion. Not to say that the nuclei of atoms don't move and wiggle and vibrate, but I tell you, those electrons are just crazy. So again, we have a kind of a still image of the, I call it kind of the Christmas tree in the middle. That is what? Our nucleus, right? And what's found in the nucleus? Protons and neutrons. And what's this cloud out here? Of course, electrons. So just to kind of finish up, here's a table that looks at those 3 subatomic particles. So let's take a quick look. Okay, we have the protons and neutrons. They are found in the nucleus. Okay, they bring mass, and then we have electrons are found in a cloud outside the nucleus. So speaking of mass, here we go. This is how much each subatomic particle weighs in kilograms. This is how much each subatomic particle weighs in a new unit just kind of developed to measure small things like atoms and molecules, called an atomic mass unit, an AMU. AMU is equal to, and I have a slide coming up here in the unit 2, atomic mass unit, not to be confused with an astronomical unit, an AU. So I mentioned that, I think I said neutron weighs 1 AMU, a proton weighs about 1 AMU, And notice how much an electron weighs, 0.00055 AMUs. So that is, that's why we say that this is negligible for in cases of, for our purposes anyway. And then the last column talks about protons are positively charged, neutrons are no charge free, electrons are negatively charged. Then we bump up again against homework. Dun, dun, dun.